So let's talk about select. Close these. Okay, here. Close all these. Not in text. I want you here. Okay. So package main, and then we are going to have two channels. And we are going to have two go routines. One is going to sleep for 10 milliseconds, and then send the value 1 to channel 1. And the second one is going to sleep for 20 milliseconds, and then going to send a value to channel 2. So two go routines, two channels, each one of them sending something. Now we would like to get something from either one of the channels, the first thing that comes available. Think, for example, you're making a DNS query. You send the same request for several DNS servers. Once you get a request, you don't really care about the others, right? This is something you want to do. Okay, so we can do a select statement. And select works on several channels. I can do case val channel 1, why aren't you happy? Oh, because it's just, I can do this. So in select statement, we have several cases. Each case is a channel operation. It can be either a send or a receive. Most of the time, it's going to be a receive, but sometimes we do a send. For example, we can set timeouts on sending. Right, so, and if you're going to run it, every time you're going to get the value from channel 1. If I'm going to make channel 2 faster, now we're going to get the things from channel 2. This idea comes from a network system call called select. Select gets a list of sockets and returns the list, a subset of this list, telling you which of these sockets you can either send or receive from without getting blocked. But unlike select, which gets a variable number of sockets to listen on, in Go select, it is in the syntax. So it can be only a fixed number of channels, and it's in the syntax. So here we have 2 channels, and that's it. Okay, so this is the basic mechanism of select. 1 or more channels, we can do it. One thing that we do a lot with selects is timeouts and cancellation. You can do this, right? So what time.after is doing is basically what our go routine are doing. It is creating a channel, spinning a go routine that slips the duration that is given, in this case, 5 milliseconds, and then sending a value over the channel. we don't really care what time that after is returning in the channel. If you're really curious, it's time, but we just care that something came out as it is. Questions?
So what happens to the other, are the other channel messages just dropped or thrown out, or?
No, they're just waiting for someone to do something.
I
We will
see.
see that. We see that later on what happens with them and how we can avoid that, avoid some problems with it. But currently, it just nothing happens. Right, so we just consume something from channel one, from currently from the time after channel. Select does not make blocking channels non-blocking. Select lets you do operations on several channels. The first one, it is available, it gets you're still blocked on the channel. If you do an empty select with nothing inside, you're going to get blocked for it. Right, sometimes you'll see people doing this, right? So this is blocks forever. Right, and we do this. So let's say you want to run the web server on one port and the admin server on another port. Sometimes what people do is they do go routine for the web server, go routine for the admin server, and then they want the main to wait. So they do a deselect, which blocks without without consuming CPU, right? Because if you do a for, you do this. This is also going to wait forever, but this is going to consume a lot of CPU. This one, no CPU.
Can we use select as a consumer for like continuously running different producers? Like in this case, you're just getting one value, but is it possible to modify this to be a consumer for multiple channels?
No.
Okay.
So it's if you know the number of channels, if you know it's 2 or 3 channels, and you can do it in the syntax, this is fine. If you want to do something like a fan in is a different operation. This is a bit more involved than doing this. But as I said, the most common case for select is for timeouts and cancellation, because now the go-routine can, on one hand, you can spin a go-routine that does the actual work. On the other hand, wait for some kind of a timer to happen, and then you can decide what to do. And we worked with time.after, and we sometimes had, if you want to manually cancel something, we send over a channel, and then we just close the channel. So the select would, once we close the channel, this case will happen, and we know. So we were passing what is known as a done channel throughout the code. But after a while, the community came out and said, you know what? We want a combination of either specifying a timeout or maybe doing a manual cancellation. Can we think of something else? And then this is where we got the context. So we can create something known as a context. Context is always created from another context. The idea is, for example, in your HTTP handler, the HTTP handler has a context. These are the timeouts set in the server. So you get this context. And then you say, you know what, I'm sending this context, but I'm also giving the database 100 milliseconds. And the ones that fire first, this is the one that is going to, both of them are going to cancel as well. So we have like a hierarchy of context that you can send over. So what you get in the handler is the time that you have to the whole operation. Then you can pass some time to the database, some time to other things. Yeah, you can do a lot of really complicated stuff with context. But the problem is that now, okay, when we want to create our own context, we need to start from one context that there is. So in the context, there is the background context. This is the primary current context for all of the other contexts. And here we can say 5 times, not millisecond. Okay. So what we get back are two things. We get a context. And what we can do is, instead of doing this, now we're going to say, actually, now we're going to do case this. Okay, so now the context has a done method. The context is an interface. It has a done method that returns a channel. And you can do an operation on this channel. You know what? The other thing that is painted in red on line 22 is cancel. Cancel is a function. And cancel allows you to manually cancel a context. Meaning you can specify a timeout, but when you say, you know, some event happened, never mind. We're done right now. And most of the time, what you're going to do is defer of cancel. Okay, so in your HTTP handler, you set up the context, and then you do a defer of the cancellation of the context. So if you're sending some work to the database or to some other service, and then the handler exits because of an error or something, this cancel gets fired, and then everybody's get notified that, hey, the allocated time for the operation is done. We don't need to do it. Sometimes we do also selects for throttling or handling load. So let's say I'm listening on messages from Kafka or something, and I want to put them in a channel for processing. I can do a select trying to send a message, and also a timeout saying, you know what, if I didn't manage to, if nobody took this message from the channel after, let's say 10 milliseconds, I'm going to drop it. So not going to. Right, this stuff gets complicated really, really fast, but this is the basic usage. And once we got context, you will see it in a lot of places, especially if you're working with gRPC. The gRPC framework in Go utilizes context a lot, both in the client side and in the service. Questions? So cancel func is returned by read timeout. And it is not, yeah, you can say that cancel is, you can say it's called when the timeout expires automatically, or if you call it manually, and then it is going to expire the context before that. Okay, so when we look at context, this is a how can I go to what is a context? Well, I'll just Google it. Okay, so context is an interface. There are several things you can query to the context. You can ask it what is the deadline, and some contexts do not have deadline, right? You can do a with cancel, meaning I just want a cancellation function in a context, and I am going to manually decide when to cancel the context. No time. So there might be no timeout in the context. There is the done, which is a channel of, you see the empty structure, which takes 0. You can ask the context for an error, meaning was the done fired already or not. So this is used for cancellation. There is a link here for a blog post on in the Go website about cancellation. Another thing, so context need to be passed around all the time. This is unlike maybe in threads, if you're looking for thread local storage and other things, we don't have that in Go. So if you, from the handler, pass something that goes to a function that calls another function, and this function is actually doing the access to the database and needs the context, you need to pass the context throughout the chain all the time. The custom the way we do it is we pass the context as a third parameter always. So always context and then the other parameters. And it's being passed around down the line of them. Because it's already being passed out, context also has some kind of like key value store. So again, if I'm going back to your web server, I can generate a request ID and stick it in the context. And now everybody that is logging, they can log what is the current request ID, so I can look at all the logs that are for this request. So there is a with value, and there is a way to extract the value from the context. And unsurprisingly, the keys and the values are the empty interface. Anything. Right. So for example, if you do authentication and then you stick it in the context, you can do from context, return a user struct. So you get the value and then convert it to user pointer and then return. Okay, so this is one way. This is setting, right? Context with one. Let's try it out. Okay, so I uploaded my code, and what I'm asking you to do now is download a file called RTB. Okay, so there is a file here called rtb.go. And let's have a look at what's inside. Okay, so RTB stands for real-time bidding. And the idea is, in real-time bidding, you are bidding on ads. So some website is going up. It is telling you, look, I'm going to upload to show this page to a user. You have 10 milliseconds to tell me what is the ad you want to show and how much you're going to pay for it. These are ad networks, or these are real-time bidding. And then the story goes is that you have an algorithm team, right? This algorithm team wrote a function called best bid. The best bid function gets a URL and returns the best ad and the best price for this specific URL. Under the hood, they're using some decision trees, maybe some data cleaning, doing some joins on the network, etc., etc. So the time it takes for this best bid function to execute varies. And to simulate that, what I'm doing is that I'm saying that the duration is 100 milliseconds, but if the URL starts with HTTPS, it's going to take only 20 milliseconds. Okay, and then I'm sleeping, and then I'm returning a bid. Ads are us, ads 17, and the price is 7 cents. Right, this is a bid. Now, what you're requested to do is this. You need to write a function called bid on. Bid on is going to get a context of how much time it has and the URL. And it should always return a bid. It should never err. What it should do is try to call the best bid. And if the best bid returns the value in time, it should return what best bid returned. If not, it should return the default bid. This is the default bid. It's the default ad with 3 cents. Okay, so you have this code, you need to fill it up, right? You need to create the context with a timeout of 50 milliseconds, and you need to write the bid on function. Enjoy. Don't forget to raise your hand when you are done. So the question is it safe to pass context across coroutines? Yes, context is exactly for that. Okay, a couple more minutes and then I will solve it. All right, so let's start by creating the context, right? So this is context with timeouts, context dot background, and 50 times time dot millisecond. Okay, so this is creating the context. Okay. And now what we do with bidon. When we do a bidon, we need two things. We need a channel and a goat. So make a channel of bits. And then we do a function that will best bid on the URL and will send the bid over the channel. Now we can do a select. And if you get it from the channel, you're going to return the bid. Right, so this means the algorithm is finished in time. We can safely return the bid. If the context is done, meaning no more time, we return the default bid. And that's it. Right, so if you run it right now, and actually look at the debug console, we see that we get a default bid because we have 50 millisecond, but it's HTTP. If we convert the URL to HTTPS, and run it, now we're going to see that we get the ad that we wanted. Okay, so it's really easy once you have an operation to add some kind of a timeout, spin a coroutine, use a channel, to select. It's a little bit of code to write, right? But comparing to other languages, to think about how you can do it in other languages, I think this is on the easy side of things when we come to it. Yeah, you would love a world where HTTPS is faster than HTTP. Well, this is my contribution. Questions about this one?
I have a general question about select. What is select?
Yes.
Like, what is the underlying data structure or algorithm that it uses? And
I really don't know.
okay,
I really
so
don't.
okay, so my follow-up question
You need to dig into the Go runtime to see what select is doing.
okay.
I
So
really don't.
is there a limit on how many channels can be select from?
Not that I'm aware of, but because it's in the syntax, so you're going to write one line per channel, they're not going to be a lot.
Okay. And
You can pass a slice of channels and do a select on them. This is not possible.
okay, got it. Is there a latency that we know that when a message will be sent from a channel and when it will be received by select, or it will be immediate?
Could be immediate. It depends on a lot of factors. How many coroutines are currently running? What's the load? Like, there's so many things that it's really nothing you can control. You can never rely on that.
Okay.
More questions?
Is there any advantage to assigning the return of best bid to bid and then throwing that onto the channel over just throwing the return of best bid straight onto the channel? I'm just curious if there's.
Oh, here I can do. You mean I can do like this? No, there's no. You can do this. This is fine.
Okay, I was just curious. Thank you.
This is the same idea. More questions? Okay. So we actually have a bug here. It is very subtle, but it exists in the time that we have a timeout. Okay, so when we have a timeout, the context of done is being fired. We're returning the default bit, but this go routine is still running. Sometime few milliseconds later, best bit is going to return, and now this go routine is trying to send the return value to the channel. It gets stuck. So now we have a go routine that is stuck, and we have a channel that there is a reference to it because the go routine is still looking at it. So the garbage collector cannot claim the channel. This is known as a go routine leak. You are leaking go routines. I had few customers, they come in, they say, we're seeing the program memory go up and up, but we can't see the issue. And I'm saying, okay, so please run the profiler and tell me how many go routines you see. And once they do that, they said, okay, now we know we're leaking go routines. So there are two solutions for that. One is we can do a select also on the go routine here and give it some timeout when it's sending. And this will free that. But the other solution is doing this. And this is buffered channel to avoid go routine. A buffered channel gives you n, or the size of the buffer. Actually, it's the capacity of the buffer. 3 send operations. Right? So if I'm going back for a minute to my Go channel and the semantics, buffer channel has send operations without blocking. Okay, so a buffer channel can have up to the capacity of the channel, free or non-blocking. Maybe this is a better non-blocking send operation. Does not affect the receive side at all. So when we look at the buffer channels, most, like 90-something% of buffer channels is exactly like this. One, to avoid go routines. That's it. That's the only thing we use.
Is there a benefit to always using buffered routine channels?
What's that?
Is there a reason to not use it all the time?
Yeah, sometimes you want semantics. Sometimes you want that when you're sending something, the go routine will unblock only when someone on the other side is handling that. This is a guarantee that you have. And sometimes when you talk about synchronization, this is important. So you want to know that. Most channels are unbuffered. Most channels in the wild. Are unbuffered. You might be tempted to have more than one in the buffer. So Uber Go. So Uber writes a lot of Go, tons of Go, and they have a style guide for Go, which is a good style guide. And they say channel size is either 1 or none. Here you will have to convince me a lot that Y64 is the right number. Okay, so either one for avoiding leaks or unbuffered, which is the most common case. But I've seen cases where it actually made sense to make the buffer size more than 1. It's easy to implement a pool of objects using a buffer channel. but apart from that, most of the time, no. Okay, so remember go-to leaks and remember this. And once we do that, it means now we have the timeout, the function exit. After a while, this go-to wakes up. It is trying to send to the channel, but it succeeds because the channel has a buffer of 1, meaning now the go-to exits. It's not blocked anymore, it exits. Now there's no more reference to the channel and the garbage collector can play. And all is good. Okay, so context and cancellations, and I give you some links to read more about that in on the Go Wiki and other places where we have. The thing is that context started outside. It started in the Golang X family of external packages, and only in when did we get the Golang? It was added, I think, 1.7. I want to say. One of the one of the versions. It was added it was added late in the game. So, for example, if you go to the HTTP package, you would expect to see context everywhere, right? We're doing network operations. Network is the right place to put timeouts and cancellation. You're not going to see it really evident in the API, and that's because context came late in the game. Okay, but it is there. You just need to look for it. So the place to find it when you're making requests is a new request with context. This is the place. Okay, so what I'm going to do is I'm going to go back for our GitHub code here. Okay, and now what I'm going to say is, okay, now I'm going to pass context. Okay, so context dot background and 3 times time dot second because my internet, yeah. And I'm going to do 6. Okay, so I'm passing this to the GitHub, and it's usually once you have functions that are aware of context, we'd start sticking it here. And now we're going to change this code. So now we're going to do request and error equal http.new request with context. And we passed it the context, always the first parameter. Then the method, http.method get. And then we pass it the URL. And then we pass the body, which in our case is nil because GET requests do not have a body, unless you're Elasticsearch. And then GET requests will have a body. And now HTTP default client.do with the request. And again, checking. Okay, so a little bit more code, but I highly recommend every time you do a network operation, put some timeout on. To one point or another, you will need it. Okay, and when we run this one with viewing the we get the result. But if I'm going to change this one, instead of time.second, I'm going to do time.millisecond. And then I'm going to run it. you see that now I'm going to get an error which says context deadline exceeded. Okay, so every time in the networking, when you're making HTTP request, please use a context. New request with context. I don't know why there is an error for new request with context. I never seen it failing, but okay. And now we're good to go. So that's one place in the standard library you're going to see context. In the web server, I said every time you get when you write a response handler, an HTTP handler, and we're going to see it as well. This is also somewhere you can get a context. Second place you can see it is in the SQL package. The SQL package took another approach. It says, okay, I have a database, and I'm going to copy everything. So I have execute an executable statement. I have execute context. I have ping to make sure that I have connection to the database, ping with context. Query the database, query with context, etc., etc., etc. So they almost double the API from the old one to the one that adding context. One thing you need to remember, like in our RTB, the fact that the context has expired does not mean that the other operation is done. For example, in databases, some of the database drivers will cancel the operation in the database if the context expires. Others will just return you an error, but the query will still run on the database. So if you have a user or a query doing select star from everything, which brings the database to its knees, it's not 100% sure that the database driver is going to cancel the context, the query itself. Some do, some don't. Most of them don't, by the way. Questions?
I'm curious, why is it called a context? And if it's only doing checking for the time.
So the context, as I said, also has a way of placing values inside, like the current user, the session ID, etc., etc. So you are passing the context of the current call or the current operation. And this context, in the way the Go is seeing it, there's two things. One, in the context, this is the amount of time you have to do something. And the second one is all of these variables that are connected to what you do. I think, right? I didn't name it, so this is my guess. More questions?
You mentioned that the certain context-based API, they would actually stop the Go routine that is going on. How do they do that?
Well, it's not stopping the Go routine, but for example, in databases, when you do the async API for the database, you basically say run this query and you get back a query ID. And then you can tell the database, hey, look, cancel this query. So this is something the database implements and the Go driver is implementing under the hood, but it's not connected to Go routines. In our case of the RTB, we don't have a way to tell the best bid to stop working, to stop calling the database or doing anything. It will continue to run in the background. So if we're going to have a lot of timeouts on the best bid, the CPU is still going to be stagnated. So canceling something from the outside, some databases and some other operations allow that, but most of them don't.
Sorry, go ahead.
Now, I said at least you can get back to the user, say timeout, and maybe cancel some other subsequent operations down the line.
And yesterday you mentioned that you cannot cancel the Go routines that are going on, but there are ways to kind of listen to it inside the routine itself. And
yeah, that's exactly this one. That's exactly that. So the Go routine should accept the context, and it should do a select on the context to know if it's done or not.
Okay.
All right, so as I said at the beginning of today and even yesterday, this is not an easy thing, concurrency. Go makes it easier, but it's not easy. It's never easy. If you can stick with sequential code, do that. I can tell you that in practice, a lot of time, the concurrency will be hidden from you. You're going to work with the Go web server. The web server is going to do the concurrency. You're just going to write a handler and do the sequential code in the handler. So a lot of time, you don't need to do that, but there are cases that it is really going to give you a boost of performance. And then all these tools, Go routines, channels, sync, atomic, context are at your disposal. You can do whatever you want. If you want to do an exercise today, the exercise I'm asking you to do is the taxi check. Limit the number of Go routines to n Go routines and see which n is giving you the best result. Right now we're spinning Go routines per file, so we have 10 Go routines, but maybe 5 is good enough. Maybe you don't need to. And then another thing to do is saying, okay, if there is an error in one of the files, I want to cancel all the rest. I don't care about checking anything else. Once there is an error in one file, I want to cancel the whole operation immediately. Not an easy thing to do, but it is doable. Maybe look at sync at the error group that we mentioned earlier. This kind. When we meet tomorrow, we are done with Go syntax and concurrency and everything, and we are going to switch to engineering. We are going to talk about the engineering of Go projects, about how do we structure the code, how do we test, how do we document, how do we run a server, how do we log and metrics, and all of the other things that are more about engineering than actually writing. So that's the plan for tomorrow. Come with a lot of questions, and thank you very much for today.